Hello, linear algebra student. This video is for chapter 4.4, part 4. We were working on this example where we want to write a vector 3, -7 with using a set which is not a basis. So the unique theorem does not apply. And you can have a combination of multiple sets of this to get 3, -7. So basically, that is what it's asking about. These sets do span out too, so every single vector can be written as a combination of them. But because it's not a basis, so there will be more than one different coordinate vectors, and we have to find two of them. So I am going to solve. So to solve the vectors, so you would use the equation x equal to pb xb. Even this is not a basis, it still work because you just want to know how you can combine these vectors to solve 3, -7, right? So basically, you are trying to see x1 times 1, 2 plus x2 times -1, 3 plus x3 times 5, 5, and somehow we'll get 3, -7. So it is as if you're solving a systems of equation of these using the augmented matrix. And if you do RREF, you will get a answer which is a parametric answer. So oh, this is really small. Let me make it bigger. Right, sorry, it was really small. 25. Yeah, so let's change into the matrix calculator, and I already enter the augmented matrix in F. Is 1, 2, -1, 3, 5, 5, 3, -7. So when I do the reduced row echelon, it becomes 1, 0, 4, 0.4, 0, 1, -1, -2.6. So I'm going to write down the answer would be, and you know that it is not a unique solution. 0, 1, oh, 0, 4, no, 1, 0. This is the prefix position. 1, 0, 4, 0.4. And 0, 1, -1, -2.6. So now these systems can be written as x1 equal to 0.4 minus 4 x3, right? x2 is equal to -2.6 plus x3, because it was minus x3 equal to this. And then x3 is 3, is equal to x3. So in a parametric form, it would be x1, x2, x3 is equal to x3. What do I have? 4, 1, 1, right? Negative 4, 1, 1, negative 4, 1, 1 plus 8.4, -2.6, and a 0, right? So this is the general solution. So when I have x, let me erase this. And I was saying too fast earlier. So let's get back to this side. Not enough space on that side. So let's get back here to write the solution. The solution would be when x3 equal to 0. My answer would be x1, x2, x3 would be 0. So I only have 0.4, -2.6, and 0. So that is the coordinate. So this is the weight for V1. This is the other is the weight for V2. And when x3 equal to 1, I would have x1, x2, x3 equal to 4, 4 plus, so this is 1, right? 4 plus 0.4 is 4.4. x2 would be, is this 0? Oh no, this is 1. This is 1. So it will be 1 plus -2.6. So it's -1.6. And the last is 1 also, 1 plus a 0, so that's a 1. So these are the two coordinate that you can write, two different coordinate vectors for 3, -7s. Just check quickly. If I use 0.4, you can see that the third one can be, take away. If you take away the third one, so these two actually can produce 3, -7. So 0.4 of 1, 2, and -2.6 of -1, 3, we can certainly show that it is equal to 3, -7. Why? Because 0.4 plus 2.6 is 3, right? 0.8 minus, so what is this? 2.6 times 3 is 2.6 times 3, 7.8, but -7.8 minus 0.8 will be -7, right? So these are the two coordinates. And that's how you find it. You solve a system equation, have all the vector column equal to x, the standard coordinate, and you will find two different combinations.